Hi everyone, my name is Sanjana and I'm a second semester student studying in Sri Venkateswara College of Engineering. In today's video, I'm going to be explaining an important topic from the subject Introduction to Mechanical Engineering. So let's get started. The topic for today's discussion is four-stroke petrol and diesel engine. Uh, so first, let's try and understand what is a four-stroke engine. A four-stroke engine is an IC engine in which the piston performs four strokes to complete all the operations in one working cycle. It can also be defined as an engine in which the working cycle is completed for every two crank rotations. The four strokes which are performed in this type of engine are the suction stroke, compression stroke, power stroke or working stroke, and the exhaust stroke. First, let's take a look at a four-stroke petrol engine. The first step in a four-stroke petrol engine is the suction stroke. During this stroke, the piston moves from the top dead center or TDC to the bottom dead center or BDC, creating a suction. This suction creates the pressure difference between the atmosphere and the engine cylinder. The intake valve is open during this stroke and the exhaust valve remains closed. The suction stroke completes after the piston reaches the BDC. Next, we have the compression stroke. The compression process starts when the piston starts to move from BDC towards TDC, which means the upward movement of the piston. Both the inlet and exhaust valves remain closed during this stroke. The compression stroke increases the temperature of the air and the fuel mixture, in which in turn makes the mixture of petrol and air reach its ignition temperature. The compression stroke continues until the piston reaches the TDC. Next, we have the power or working stroke. At the end of the compression stroke, the spark plug electrics creates the spark at the spark plug. The mixture of the air and petrol starts to burn with the spark. This is the ideal stroke of all the four processes. This stroke produces power and hence it is also known as the power stroke. Both the inlet and exhaust valves are closed during this stroke. The piston moves from TDC to BDC, and when it reaches BDC, all the fuel and air mixture present in the cylinder will be burnt and produces heat. The heat increases the pressure in which acts on the piston. Hence, the piston starts to move from TDC to BDC. It is also known as the expansion stroke. Finally, we have the exhaust stroke. The exhaust valve is open and the inlet valve remains closed during this stroke. The burnt fuel and air mixture after combustion has to be removed from the combustion chamber and evacuated to the combustion chamber to begin the next cycle. The exhaust valve opens the piston and moves from opens and the piston moves from BDC to TDC. So over here we have a table showing us the initial and final positions of the piston in each of the different strokes and also whether the inlet and exhaust valve is closed. And we can also see that the angle of rotation of the crank is also given. Next, we have the PV graph of the four-stroke petrol engine. Here, the line AB, the curve AB represents suction of air and petrol. The curve BC represents the compression of the mixture. Curve CD represents the constant volume combustion. Curve DE represents the expansion stroke. And EB represents the part where the exhaust valve opens. And curve BA represents the exhaust of the combustion product. Okay, so now we have a four-stroke diesel engine. So the first step is the suction stroke again. During this stroke, the piston moves again from the TDC to BDC and hence creates a suction. This suction creates the pressure difference between the atmosphere and engine cylinder. The inlet valve is open during this stroke and the exhaust valve remains closed. The air from the atmosphere enters into the engine cylinder and the suction stroke completes after the piston reaches BDC. Next, we have the compression stroke. The compression process starts when the piston starts to move from BDC towards TDC, which means the upward movement of the piston. Both the inlet and exhaust valves remain closed during this stroke. The compression stroke increases the temperature of the air and it continues until the piston reaches TDC. Next, we have the power or working stroke. At the end of the compression stroke, the diesel is injected into the engine cylinder in the form of a fine spray. The hot compressed air and diesel mix well with each other. This causes the diesel fuel to reach its self-ignition temperature. The diesel fuel starts to burn, and the combustion of diesel leads to the increase in the pressure and temperature inside the combustion chamber. This pressure acts on the top surface of the piston and pushes the piston downwards, and this causes to produce the working stroke. This is the ideal stroke of all the four processes, and this stroke also produces power. Hence, it is called the power stroke. Both the inlet and exhaust valves are closed during this stroke. The piston is moving from TDC to BDC, and when the piston reaches BDC, all the fuel and air mixture present in the cylinder will be burned and produce heat. The heat increases the pressure which acts on the piston. Hence, the piston starts to move from TDC to BDC, and it is also known as the expansion stroke. And finally, the last step, which is the exhaust stroke. The exhaust valve is open and the inlet valve remains closed during this stroke. The burnt fuel and uh, air mixture after combustion has to be removed from the combustion chamber and evacuated to begin the next cycle. The exhaust valve opens and the piston moves from BDC to TDC. And again, we have the same table here. And we also have the PV graph of a four-stroke diesel engine. Over here, curve AB is for the suction of fresh air. BC represents compression of air. CD represents constant pressure combustion. And DE represents the expansion stroke or the power stroke. EB is where the exhaust valve opens, and BA represents the exhaust of the combusted product.